And, thank you everybody for being here and welcome to our poster presentation on the exploration of open science practices within the geosciences. Okay, my name is Allison Sowers and I go to Front Range Community College where I study geospatial science.
My name is Jimmy Swift and I'm a recent graduate of San Juan College's geology program.
The goal of our project is to highlight the importance of open science by utilizing open science principles and practices to establish a digital archive of interoperable geochemical data for the U.S. Geological Survey. For some background on our project, the USGS is responsible for collecting and sharing many different types of data characterizing Earth systems. This includes earthquakes, floods, landslides, volcanoes, droughts, fires, and wildfires, and geomagnetism. Our focus this summer was on the Geo Archive project, where we are documenting an information management protocol for data extraction from National Instrument NI 43101 technical reports and the archival process for these reports. The problem we are trying to solve with this project is the accessibility of geochemical data within the USGS. By creating a digital archive with interoperable data, we can enable better access to these important data sets. Our project is focused on the importance of open science and how it can positively impact scientific research. Open science makes data available and interoperable. The goal of open science is to increase the reproducibility and integrity of academic research across all sectors, including but not limited to ecology, geology, climatology, and hydrology. Our subject matter for the Geo Archive project is centered around geology and geochemical data. The goals of open science are achieved through collaborative networks that remove the barriers involved in sharing methods, tools, or data during the research process. Through open science practices, we can accelerate scientific research and improve the trustworthiness in our results. The figure below shows many of the components of open science, including open access, open infrastructure, open notebooks, open data, open educational resources, open evaluation, and open source sharing. I will now hand over the presentation to Jimmy, who will talk more in depth about the Geo Archive project.
Thank you, Allison. The goal of the Geo Archive project is to promote open science principles through creating standard operating procedures for geochemical data. These technical reports document a summary of scientific and location information about geochemical samples from mining sites around the world. The NI 43101 technical reports are produced by Canadian mining companies and are necessary for financial disclosure regulations in Canada. These reports are archived within the USGS's Mineral Development Project database, which is located in the Science-Based Catalog. So why is this important? Increasingly, we are called upon to share more of the scholarly record from all the data we collected, processed, and analyzed to the models of the conclusion was based off of. Knowing the steps and methodology of how we reached a conclusion is very important, as any scientific finding must be reproducible. Publishing standard operating procedures will aid in the reproducibility as well as the integrity of research. We published multiple standard operating procedures on the open science platform protocols.io that extract and archive the data and metadata from each report. One of the problems with the NI 43101 reports is they are consistently being referenced in research projects. However, when someone wants to access this reference for that specific project, it is not available to that person or institution. Our process for making these standard operating procedures began by us analyzing the problem of data extraction with the NI 43101 reports. We then pulled these data files from cdar.com while recording these steps in our protocol. cdar.com is a website that houses public securities documents and allows users to access the data. We then designed a second protocol used to either publish reports on sciencebase.gov or creating a bibliography library in Zotero, while looking for any identifying metadata in these reports. We then combined the two protocols used for extraction of the NI 43101 reports and publication of the reports to either sciencebase.gov or Zotero. Looking forward, these types of SOPs can be really beneficial to the USGS for managing large amounts of analytical data that reference back to specific protocols documenting the use of different instruments and detailed analytical methods important to scientific methodology. Some open science tools that we used during this project include protocols.io, which was a useful tool for designing protocols that were used to retrieve and record formalized scientific research data. Protocols is a centralized platform for the collaborative creation, management, and sharing of research protocols and methods. We also use Zotero. Zotero was used to manage bibliographic data or related research materials. It is a free, easy to use tool that helps collect, organize, cite, and share research. I will now hand the presentation back to Allison, who will finish talking about our open science tools.
Thank you, Jimmy. Some of the other open science platforms we utilized for our project were the Open Science Framework, which we used as an open shared archive for our project. OSF is a free open source web application that connects and supports the research workflow, enabling scientists to increase the efficiency and effectiveness of their research. We used Trello as a task manager for this project. Trello is an organizational tool that keeps team members on track. It can be used for any size project or team. Trello is a free, flexible, and visual platform that enables users to manage and organize their projects. We also utilized GitHub to publish our Python code that we made to create an archive of our Trello board. This was done to keep our work transparent. It also allows anyone to go back and look at the steps that we took to achieve our project goals. GitHub is a web-based platform used for version control. It simplifies the process of working with other people and makes it easy to collaborate on projects. Below, we've got a couple QR codes that will direct you to our final products, including a standard operating procedure for data archiving through Zotero, a standard operating procedure for data extraction from CDAR, and our OSF workspace. Thanks to this internship, we have developed many skills, such as creating standard operating procedures, gaining a better understanding of Python coding, becoming familiar with all of the open science tools listed above, and due to the program being a hybrid of in-person and remote, we have harnessed our Zoom and work from home skills as well. This project has emphasized the importance of documenting and publishing scientific protocols. By doing so, this makes scientific research more reproducible and instills integrity in the work being published. We're grateful for the opportunity this internship has given us to jumpstart our careers within the geosciences. We would like to thank our project mentor from USGS, Guy Bristol, for sharing his time and knowledge with us. We would also like to thank our mentors from UNAFCO, Kelsey Russo-Nixon and Anika Knight, for providing us with the opportunity to participate in this academic and professional development program. We also want to thank the Geological Society of America for providing us with the On to the Future Award, which will fund our travel and enable us to present at the GSA Connects conference this fall. And finally, we would like to highlight a land acknowledgement for the USGS Denver office. We feel it is important to acknowledge that the office is located within the traditional territory of the Cheyenne, Ute, Arapaho, Sioux, and Apache peoples. Thank you so much for taking the time to listen to our presentation. Are there any questions?
Great job, you guys. So if you have any questions, you can type them in the chat and we'll read them to you, or you can raise your hand and unmute yourself. Yes, Beth.
Hi, great job on the presentation. Can you tell me a little bit more about how other people would be able to use what you found? I think you mentioned something about the Python codes or, but like if somebody wanted to use what you worked on in the summer for better open science, open access science. Tell a little more about that, please.
Yeah, specifically for this project, the two best things would be our standard operating procedures for data extraction and archiving, those two processes, and those would be in our products. We've got like the protocols right here. So you can literally, it's basically a step-by-step instruction guide on how to extract the data from the CDAR website and then how to archive it properly so that it can be easily accessed in the future. So those would be the two, probably the best two products that could be used in the future.
Do you have any plans for publicizing those?
Yes, so we're in the process of publishing those right now, and we'll have that done by the end of this week.
That's great. Thanks.
There are some questions in the chat. Christine Puskas asks, how far back do the technical reports go? And are the instructions available on the USGS website?
As far as the date of the reports, I'm not 100% sure how far back those go. I know that they've been used for a very long time, and it is a official documentation for the Canadian Securities Exchange. commission. So I can't give you an exact date on that. And then for the second part of the question, sorry, what was the second part?
Are the instructions available on the USGS website?
Not yet. No, I think we're going to be being able to make them available or linking them to to a USGS website for our project. But right now, just the way we can access them is through our poster and through the QR codes.
Great questions. I have one. Is there anything you think you might do differently if you were doing this over again?
I think the only thing that I would say is if we could do the whole session or the whole internship in person, that I feel it could have been a little bit more. I know obviously because of COVID and everything, but just we had such a great time in the beginning when we all were together. So that would be like the only thing I think I would change about our entire experience, would be just be a little bit more time together.
And I would like to add maybe just a little more time in the project working with this project. That would have been a lot nicer, I guess. We would have had a few more products to this project, but that's okay.
Christine has one follow-up. She says, thank you for the questions you answered already. And she says, I was wondering if you had to deal with pre-digital documents from whenever the reports were first mandated.
No, so it's nice because all of the technical reports, they are all digitized. However, they are in PDF format. So the issue was us being able to find the right kind of technology and tools to extract the data from PDF documents. And actually it's the University of Wisconsin that we will be, like the next step in this project will be sending all of the reports to the University of Wisconsin, where they have a specialized AI that can go through and read the PDF documents and extract that data in another way. So thankfully it is all digital, but there are still issues with extracting data from digital documents.
Okay, those were great answers. Oh, no, go ahead, Shelley. Do we have any final questions before we move on to our next speakers? Okay, great job, you guys.